Jérémy is a Leverhulme early career research fellow at the University of Stirling in sunny Scotland. Is a conservation biologist with a broad interest in wildlife ecology and conservation using emergent bioacoustic methods. His research focuses on assessing the impacts of anthropogenic stresses on biodiversity, especially bats. Good man, I'm a bat guy as well. Birds and recently bees. He graduated with a PhD in biology from the University of Bristol. So I'm going to stop talking and I shall pass you over to Jérémy.
Hi everyone, I am Jérémy Froidevaux from the University of Stirling in Scotland. I am also part of the core team of the Silent Cities project. In the following 10 minutes, I will be talking about the data validations and data visualizations of the project. If you remember the last few minutes of Nicolas' talk, we analyzed the data through different prisms. We first manually labeled a subset of recordings and classified geophony, biophony, and anthropophony events. We also derived a suite of ecoacoustic indices for each recording and implemented pre-trained neural networks to classify each recording in different classes that we then regroup in 3 categories. And again, there were the 3 categories were the geophony, the biophony, and the anthropophony. For the data validation, the goal was to assess whether the acoustic indices and the audio tagging types we calculated were representative of what we could hear in the recordings. This was done using the data from the manual annotations of recordings. So in total, 1,540 minutes of sounds was manually described from 33 sites from many participants in Europe, America, and Australia. All 3 major types of sound were detected, namely geophony with wind and rain events, the biophony that was mainly dominated by bird calls and, to a lesser extent, insect stridulation, and finally the anthropophony with many cars and human talking. We ran many models to investigate the strengths of the relationship between the ecoacoustic indices and tagging type with the percentage of biophony, geophony, and anthropophony that we manually assessed. Here, I present you the output of these models in these figures with the dots corresponding to the estimates of these relationships, in other words, the slope, and the bar corresponding to the 95% confidence interval around the estimate. When the confidence interval overlaps 0, it means that the relationship is not significant, and positive estimate represents positive relationship, while negative estimate represents negative relationship. So looking first at the audio tagging type, we're very glad to see a very strong relationship between the geophony tag and the percentage of geophony within the recording, between the biophony tag and the percentage of biophony within the recording, and finally between the anthropophony tag and the percentage of anthropophony within the recording. So the tagging classification arising from the pre-trained neural network seems to work pretty nicely. For the ecoacoustic indices, we were also happy with the results obtained. So looking at the relationship between the geophony and ecoacoustic indices, dB and ACT seems to be very good predictors of the percentage of geophony in the recording. So when we get high values of dBs and ACT, it corresponds to high percentage of geophony in the file. Looking now at the biophony, we have several indices that were positively related to the percentage of biophony, such as ACT, Bioacoustic Index BI, and NDSI. So we had different kind of indices for BI and NDSI, but I won't go too much in details here. And actually, it's very interesting for ACT to see to be a good predictor for both biophony and geophony, and it's actually also a good predictor for the anthropophony. So here are the results for the anthropophony. So we found a strong relationship with the amount of decibels, but also with ACT, as I said before. We also found that the anthropophony was negatively related to NDCI. So altogether, we can see that some indices may be more relevant than others to describe the different sound types in the recording. And dB seems definitely a good predictor of anthropophony. So we then look at how dB varies across time and in different sites. So I will use only dB for the data visualization, but we can also look for the different kind of ecoacoustic indices. So the first and best example we obtained was with this site located in Toulouse city center in France. So in the plot, you can see the amount of decibels in the y-axis each day at 8 AM, so in the y-axis, before, during, and after the hard lockdown we had in France. So this started the 17th of March 2020 and ended on the 11th of May 2020. So here we can all appreciate the drop in decibels amount when the lockdown was implemented, and then an increase when we got out of the hard lockdown, but still with some restriction measures. So the amount of decibels didn't go back to before lockdown. And the small variation you can see here in dBs correspond to the working days and weekends. So it's very interesting to see that even during the hard lockdowns, weekends were quieter than working days. And here I show you an example of spectrograms we got from Toulouse at 8 AM during the different periods. I will just play the first two with the first noisy one with a car passing by, and in the second one a mix of bird calls. So hope it works. So the Toulouse site was very neat, but we also have many sites where this pattern is not obvious at all. And here is a site in Santiago in Chile. So hard lockdown was, I think, after the 26th of March, but the street continues to be very busy all along after lockdown. And we can also see the weekdays, weekend patterns with a variation here. But as I said, it's not, we have many sites like this where we can't see any strong variations of dB before, well, we more, at least during and after hard lockdowns. So here again is the spectrogram of some selected sounds in Santiago. So let's play them. Yeah, so this second one is a bit quieter than the first one, where we can hear a car and I think some people talking a bit in the background. So to help with the data visualizations, we also developed two data visualization apps. When I say we, it's actually Nicola Paciusco with the help of Nicola Farrugia. And these applications are very useful to see the output of the neural network and the ecoacoustic indices alongside the spectrograms of the recordings. And we can see them either at the recording level, which were 1 minute file, or at the site level. So we can select any site in the world where we have data for, and we can go through all where we can see different patterns of different kind of ecoacoustic indices with the spectrograms. Okay, finally, 2 words regarding the final dataset, the data paper and the codes. So we are currently preparing a data paper to be submitted soon in Scientific Data. So along with the paper describing all the steps of the project, we will provide to the community the ecoacoustic indices and the audio tagging of each recording we cut in all the sites. And of course, we want also to provide the raw acoustic data, but we still have some work to do for the raw acoustic data. And like the work we are doing now is to remove, using different kind of algorithm, the speech that we get in different recordings because they are considered as sensitive information. And besides that, it's also a bit complicated at the moment to find a repository where we can store the 18-20 terabytes of data in the long runs, but we are looking at different kind of options. And of course, everything will be open accessed, but we ask to cite the paper for any use of the data. So the use of the ecoacoustic indices or audio tagging type or the raw acoustic data. And all the analyses have been done using open source software, and there are a lot of people to credit here, whether for the calculation of the ecoacoustic indices or the use of the audio tagging. So we are very grateful to these people, and the codes we developed are already available, but it's still a work in progress, and this will be under the MIT license, which is a very permissive license, so you can use them again for your respective work if you want to. So that's it for me, and that's it for us, I think. So thanks everyone again for listening to this seminar. We are here to answer any questions. And of course, thanks to all participants of the Silent Cities project. Thank you very much.
Thank you very much. What I love about that last slide was, if anybody contributed, did you spot your name on there? So if not, you missed it. No, well, thank you everybody for contributing, and thank you, Jérémy, for that presentation as well. We have quite a few questions coming in, and please keep firing them into the chat where I get them sort of passed to me by one of the many elves that's working in the background. Just a quick question on the data. It's probably going back to Amadine's section, really. But did you when you got files that were clipping, that were just too loud, did you disregard those? Did you take them out of the data set, or did you just leave them in?
I think they will be in the data set. Maybe we'll remove the calculation, those are indices, because if the indices is calculated on the clipping part, that's not very relevant. So I think we'll probably do something like this, where
yeah, it's when those buses go past and everything
but
else.
the recordings will not be erased or deleted.
And it was interesting, Joe, what you were saying about the like human speech, and
You muted, Jérémy.
Well, capturing sort of speech on recorders. I mean, this is a moral dimension I think probably nearly everybody on this this webinar probably has to face from time to time. And it was interesting the way that you're trying to actually remove that sound. Is your idea to remove the sound or to kind of mask the sound?
I think we don't know yet. I think first we wanted to remove the sounds, and at least we won't put like the WAV file online with speeches, because a lot of detectors or recorders were placed at balconies or next to the houses, so we can really hear different kind of discussions with it out or inside the house. So we really want to avoid to like show this kind of data and make it like open access. So I think we will exclude it, but I think we can still provide some audio tagging with this, and the ecoacoustic they will be provided also for this kind of file. Yeah.
No,
well, if you want to add something, Amandine, or
I think
I have nothing to add. Yeah, the data won't be erased again, but we won't make them free to use by anyone, probably.
Yeah, it's interesting how you're approaching it, because it's a difficult thing to approach, really. Okay, please, can you talk a bit more about the neural network you used and why you used it?
Nicola.
Yeah, no, I think we had this discussion last few days actually. I think the audio set is quite well known and is quite large. And that's why I think we wanted to use this first. So the backbone of the pre-trained neural network with the audio set is quite good. And after we just wanted to play with the embeddings that came from this pre-trained neural network. Of course, there are like other options, but when we look at different options, I think this one would be the best one. And I think also the two Nicolas actually are using this audio set with their own data, and they were more used to the architecture. Yeah, exactly, Nicolas. Yeah.
I've got a quite fun question here. So it's in two parts. How many unique species have you recorded in the recordings for the project? And any recordings stand out to you? What's the funniest thing you've heard on the recording?
That's a tricky one.
Yeah, we didn't listen much to them actually. We're dealing with like getting them and like storing them, and yeah. I guess one thing that I found very powerful was at the beginning of the lockdown, I think it was 8 p.m. every night, people were going out on balcony and yard and clapping at all the people going out and working in hospital, you know, like kind of a support gesture. So we have that recorded, and that was kind of moving. Funny, I don't recall anything funny though, sorry. That time was pretty dark, I guess.
Yes.
Or fun, yeah. But maybe, yeah, I don't know, something else.
But for the first part of the questions, we don't know how many species. We haven't run any algorithm to detect even like roughly how many species there were. But I think from the annotations, there were some, I don't recall, but there were some pretty funny animals. They were like annotated in the 1,500 hours of recordings. Some, I don't remember, but it was like maybe I think it was some snakes. So snakes very close to the house, and I don't remember if it was a rattlesnake or
Don't worry. We've got loads of questions coming in now. Sounds like a great project and even greater infrastructure you created. Congratulations. There you go. I think it can be reused and it should be continued apart from lockdown projects. So in other words, keep going. In other words, a data sharing is still undeveloped in ecoacoustics. So this project might be a starting point. I don't know whether you've got any comments on that, but they basically someone wants you to carry on. Don't stop now.
I think we cannot. Actually, we're very limited in resources. So this project is 100% not funded. So it's all free time from the participant and us. And mostly the problem is the limitation in space, the storage space. And also we didn't find a sustainable way to do data sharing. We tried and we kind of handled it as much as we could, but to have something long-term, I think we're not yet there. The infrastructure are not, but we didn't find anything very sustainable for something very long in terms of sharing and storing.
I mean, that's probably something for the 250, 300 people that were started on this, that, you know, if you've got ideas and you can think of solutions, then let us all know, because it would be good for this not to just be a short-term, but long-term, not just project, but data storage, and maybe even paying some people that are doing some really hard work would be better. So.
Yeah, I think there were some suggestions in the chat from Klaus.
Excellent.
So thanks for that. Yeah, we look
coming through. Excellent. Yeah. Would love to have a description or access to code for automated removal of speech when you accomplish this. Will you describe this in the data paper?
Yes, definitely. Yeah. So the goal of the data paper is really to explain all the steps to like how we process the data. So from like how do we collect it to what you will get from that data, but also you get the raw data as well, so you can cross-check and do other things with the data. But all the steps like we'll be implementing will be in the data paper, and I think there are good options to remove the speech.
And all the code will be available through a GitHub page, so you can download the code and do whatever you want with it.
Excellent, excellent. So basically, they're giving you things. That's basically what it is. This is PhDs and postdocs are just waiting to happen.
Yeah, we're done with this project now. Go ahead, do what you want.
So how useful do you think acoustic indices are at these very large scales? Are they likely to be better at smaller spatial resolution where they can perhaps be tailored to particular types of soundscapes? I suppose it's comparing apples and apples as opposed to the globe, but you're the experts. I'm sitting back.
I think it's hard to use them without knowing a bit about the environment behind it. So you will always need to know a bit about the environment. You cannot just gather the indices and not. So we will take into account the climate, for example, because that, of course, that changed a lot about what climate, the type of environment is very important to know. So I say even if you want to do something large, you still need basic information to be able to interpret the indices the best way you can.
Excellent. And then one quick final question, which is, it's a biggie. What lessons have you learned from running such a large project? And would you do it differently if you had to again? I think you might have answered the second part, but what are the lessons that you've learned from such a huge, huge project?
Should I go first? Okay. Well, a lot of technical aspect about how to handle, how to communicate, how to create like open source forms, and like how to deal with such a project. So that a lot of things like this. And also, I learned that such a project is doable with just like 5% dedicated to it, and a lot of participants like joining your efforts. So I think it's very hopeful about this community, really willing to get together and do like cool work. So as you said, we were like, every time we have like 4 SM4 here, 5 SM4, someone else has some like, and see if we gather all the force like together, we have so many recorders out there, as you said. And so I think it's kind of hopeful for the future to like, if you have an idea, just share it. But you need to like have a kind of a strong idea of what you want to do, maybe a start and end date so people can like manage to like, okay, I can participate with 1 or 2 recorders doing this. But I think we should use this strengths that we have a bit more in the future. It's doable. We proved it. So I guess that's what's a happy thing about this project.
Yeah, and I think what we learned also is how to deploy this kind of project in a very short term. And we're like communicating with each other a lot during that time, and we got a lot of media attentions also. So he was dealing with getting the media, getting like while collecting the data as well. And I think that was a very good experience to, for this kind of thing. And personally, I think I learned a lot about project management, I guess. And collaborations was so great at that time. When you are in the lockdown, so you are maybe like you can still work on your projects, but it's not the same. And suddenly, like you have like a purpose. Like everyone is doing this. It's share, right? So I think this was very cool to do.
Yeah, some participant reported us that helps dealing with the anxiety of the situation to have something to do every day and like participate to something bigger.
Yeah.
But what I said that was the last question. I lied. There's one more, which is it's kind of nice, and it'd be nice to end on really. You talking about the participants that contributed, and you'd got artists that were amongst it. So this is a question on that really, which is quite nice. Do you have any limits to the scope of how the data might be used? I'm wondering about poetic and or creative uses.
Yeah, it's very often that our ecoacoustic community is contacted and work with artists. So, well, yeah, I don't know how we can be involved ourselves, but the data are there, and if they want to do anything with it, we'll be very happy. If that inspire something in the art field, that would be great. Yeah,
this could be a step up from Bernie Krause's in installation. This could be sort of 4D rather than 3D.
Yeah, and we are like recordings of rivers and different kind of geophony, which is quite nice to play with, I think, as an artist. But yeah.
Yeah, did you get anything like things like earthquakes, or did you actually get anything like that?
I don't record for earthquake, but I remember recording with thunder.
Yeah,
yeah. So it was, yeah. Suddenly you can hear like the thunder storm coming, so it was quite cool.
Yeah, excellent. Well, look, I can't thank all three of you. I know the third person's not here, but he's obviously still done lots and lots to contribute as well. But and the whole of the team that was involved in this, I really do want to thank you, and I think everybody here does as well. So thank you very, very much. There's just enough time, believe it or not, to do another soundle. So we thought we'd do one more soundle to see if we can get 2 out of 3 rather than just like we're 1-on-1 at the moment. So so we'll move on to soundle. But thank you again so much for attending and for getting up early as well, Amandine.
Thank you for inviting us.
Yeah, and thanks to all the participants.
Yeah, again. Of course.
Yeah,
definitely.
Great.